This is the fourth video for Unit 5, and in this video we're going to talk about evaluating trig functions at special angles, and also, if we know the ratio, how then to find the angles. So kind of going both ways here. So let's start with, we've already evaluated trig functions at quadrantal angles, and I remember I told you that when I first learned trig, I would put on my page this little unit circle with the coordinates. Again, unit circle R is 1. And this would help me when I was evaluating trig functions at the quadrantal angles. Well, then another thing that I put on my page, and R is 1, unit circle. Another thing that I put on my page, which you learned in geometry, was the ratio of the sides in some special triangles. And in class, I went through, or I reminded you how this came to be and how to derive the ratios. But for here, I'm just going to actually put the ratios down. So if we're in a 30, 60, 90 triangle, opposite the 30 is 1, opposite the 90 is 2, and opposite the 60 is root 3. And then for the 45, 45, 90, it's 1, 1, root 2. And so I would often put that on there. Sometimes, especially for you just learning radians, it may be helpful to get in the habit of saying pi over 6 and pi over 3. And for 45, pi over 4 and pi over 4. Just to start thinking in terms of radians. Okay, so say we were talking about, I'm asking you to find the, before getting there, I should say sometimes people prefer to always think of the hypotenuse as being 1, to think of always being in the unit circle. So you're welcome to do that, and in which case, when you think about the different ratios, so if we wanted to make that hypotenuse 1, if we were thinking about the unit circle, we could also just think about the ratios as 1, and then this would be 1 over root 2, or root 2 over 2, 1 over root 2, and same with if we thought about the 30, 60, 90 triangle. We would have, if the hypotenuse is 1, we talk about opposite 30 being 1/2 and opposite 60 being root 3 over 2. Either way, I tend to just stick with the ones in yellow, just kind of, that's how I learned it, but whatever is comfortable and easier for you. Okay, now these are all fine if our angles are acute, but what if our angles are not acute? How can we evaluate the 6 trig functions at those angles? And we use something called a reference angle. And a reference angle is the angle formed by the terminal side and the closest x-axis. So that is very important. Angle formed by the terminal side and the closest x-axis. So if you are drawing a triangle, in order to come up with these ratios here, you want to draw the triangle from the terminal side to the closest x-axis. Let's do an example in degrees, and then we'll do some in radians. So let's talk about, evaluate the 6 trig functions at, let's say, 120 degrees. So let's draw an angle at 120 degrees. So this is 120 degrees. The reference angle, as we just stated, is the angle formed by the terminal side and the closest x-axis. So this would be my reference angle. So in this case, the reference angle would be 60 degrees. And when I form my triangle, as I stated, it's going to be from that terminal side to the closest x-axis. And so I've got my 30, 60, 90, and then I'm going to put my labeling, but you have to be cognizant of the fact that I'm in the second quadrant where x is negative. So instead of just doing 1, 2, root 3, I'm going to do -1 for x, y is positive, and r is always positive. So if I want to talk about, so I've got, so if I want to talk about the sine of this angle, or actually maybe I should, sine of 120 degrees is going to be equal to the y coordinate over r. So I've got root 3 over 2. And then I could do cosine of 120 is going to be negative 1/2. Tangent of 120 is going to be negative root 3 or root 3 over negative 1. Secant of, let's do cosecant. All right, let me erase that. Let's do cosecant of 120. So cosecant of 120 is the reciprocal of sine. So 2 over root 3, I'm going to say 2 root 3 over 3. Secant of 120 is negative 2. And cotangent of 120 is negative root 3 over negative 1 over root 3 or negative root 3 over 3 if I rationalize it. Okay, so let's do another. Actually, let's do a few specific, and I'm going to talk about 2 ways to approach this. Okay, so let's, I'll stay on this page for a little bit, and then we'll go to a new page. Okay, so let's do, if I say evaluate, sine of 330 degrees, and let's do tangent of 225. I don't know why I keep doing 215, 225. And then we're going to do some radians shortly, but okay, so sine of 330. One way we could think about this is what we just did before. I'm going to draw 330, which is going to be in quadrant 4. And then I think about drawing my triangle here. And the reference angle is the distance, the angle formed from the terminal side to the closest x-axis. So in this case, that would be 30 degrees. So I'm 30, 60, 90 triangle. And I do my labeling. Opposite the 30, it's going to be negative 1 because the y value is negative. Opposite 60 is going to be positive root 3. And then I've got 2. So the sign here is y over r. So it's going to be negative 1/2. Now, I actually don't do that. Although this is totally fine. I find most kids do like to draw the triangles. I instead first think about, okay, sine of 330. I first think what the well, it's one or two things. First, actually, maybe I do sine of 330 and I think where that is. And I realize that that's in quadrant 4 and sine is negative in quadrant 4. So I know my answer is going to be negative. I know sine of 330 is going to be a negative ratio. So again, I first think about where it's falling and is the trig function, is that ratio positive or negative? So it's going to be negative. And then I think the reference angle. The reference angle for 330 is going to be 30. So this is going to equal negative sine of 30 degrees. And then I go up to my triangle that I've drawn on my page and I see that, okay, 30, the sine of 30 is 1 over 2 or 1/2. So it's going to be negative 1/2. So again, I first determine what quadrants it's in and that will determine if the ratio is positive or negative. And then I think of what the trig function is at that reference angle. Let's do both ways again with tangent of 225. Okay, so drawing 225, that is landing in quadrant 3. And if I drop my create my triangle by dropping that altitude to the closest x-axis, and the reference angle is going to be 45. So I'm in a 45, 45, 90 triangle and doing my labeling, both x and y are negative. And so the tangent of 225 is y over x, so negative 1 over negative 1, or just 1. Okay, the other way to think about it is tangent of 225. All right, 225 is in quadrant 3. where tangent is positive. So tangent 225 is going to be some positive ratio. You don't have to put the positive, but, and what's the reference angle? 45. So it's going to be the positive of tangent of 45. And then I go up to my little triangle that I've drawn and I realize, okay, the ratio is 1/1. So it's going to be equal to 1. So whatever you find easiest, again, totally fine to always draw a triangle. I just tend to think of if it's positive or negative and the equivalent and the reference angle. Okay, let's do a few with radians now. So evaluate the following. What if I said secant of 2 pi over 3? Let's do tangent of 11 pi over 6. Let's do cosecant of 5 pi over 4 and tangent of 5 pi over 2. Okay, one thing to keep in mind is that knowing that pi over 3 is 60, pi over 6 is 30, pi over 4 is 45. That's helpful. Hopefully soon you won't have to have that written down and you'll know. So 2 pi over 3, well, let's talk about the way that I tend to, like to do it is I think about 2 pi over 3, what quadrant does that fall in? And I do not convert it to degrees. Instead, I think, all right, pi would be 3 pi over 3. So this is 1 pi over 3 less than that. So I must be in quadrant 2. And in quadrant 2, secant is negative. So this is equal to negative secant of, and what is the reference angle? Well, the nice thing about the reference angle in radians, it like jumps right out at you, pi over 3. So negative secant of pi over 3, and I'm going to have to draw my little triangle again. So 1√3, 2. And secant of pi over 3, that's going to be r over x. So it's going to be equal to negative 2. All right, let's do tangent of 11 pi over 6. Again, I'm not converting it to degrees, but I do know that 12 pi over 6 is 2 pi. So I'm 1 pi over 6 less than that. So I must be in quadrant 4. So quadrant 4, tangent is negative in quadrant 4. So it's going to be equal to negative tangent of whatever the reference angle is. And it's jumping right out at you, pi over 6. So negative tan of pi over 6, that's going to be negative 1/√3. And you can, honestly, you can leave it like this, or negative √3 over 3. Okay, let's do a couple more. Cosecant of 5 pi over 4. Well, 4 pi over 4 would be pi. So 1 pi over 4 more than that is going to end up in quadrant 3. So this is going to be equal to cosecant of the reference angle. Oh, sorry, not cosecant. It's going to be negative cosecant, right? Cosecant is negative in quadrant 3 because sine is negative as well. The y value is negative. And the reference angle is pi over 4. And remember our 45, 90 is 1/√2. So r over y is going to just be √2 over 1. So this is negative √2. Okay, tangent of 5 pi over 2. Well, 4 pi over 2 would be 2 pi. So I'm 1 pi over 2 more. In other words, I've gone around 1 revolution and then I'm at pi over 2, which is 90. So we're not talking about a reference angle here. We're talking about a quadrantal angle. So I'm up at 90 or pi over 2. And remember, if we're in the unit circle where r is 1, the coordinate is 0, 1. So tangent is y over x, so 1 over 0, which is a problem, so it's undefined there. And sometimes that'll happen. You'll get an answer where it's undefined. Okay, so that's a little bit, and this, honestly, the way to get good at this is just to practice. So that's why we give you lots of practice with this, because you get more familiar with hopefully thinking in radians and getting used to that, and just getting used to either drawing triangles or thinking about positive and negative and reference angles. So let's now just do one last thing, which is to go the other way. If you know the ratio, how can you find the angle / angles? All right, so again, I'm going to work in radians and say the directions were find theta in 0 to 2 pi. So find all angles between 0 and 2 pi that meet the following conditions. So let's do, what if I said sine of theta equals -1/2? So, and again, you may want to, before we jump into this, maybe we want to have our little diagrams up. So we've got 1, √3, 2. We've got our 45, 45, 90, which is 1, 1, √2. And then we've got our unit circle with the different coordinates, 1, 0, 0, 1, -1, 0, 0, -1 to help us. Okay, so sine, first thing I think of, okay, sine is negative in which quadrants? Okay, it's going to be negative in quadrants 3 and 4, where y is negative. That's the first thing I think of. And then I think of what reference angle, when I take the sine, do I get a half? So I think of the absolute value. If it's negative, I just think of what's the positive, because when I'm looking at my triangles, everything's positive. So the reference angle so I know it's going to be the 30, 60, 90 triangle, because I'm not involving √2 here. So it's opposite or over hypotenuse being a half. The reference angle is 30. So in radians, that's pi over 6. So the quadrant 3 angle with a reference angle of pi over 6. Well, 6 pi over 6 is pi. And I want to get into the third quadrant. So I want 1 pi over 6 more. So it's going to be 7 pi over 6. In quadrant 4, if that reference angle, again, we wanted 1 pi, we want this to be pi over 6. In quadrant 4, we want this to be pi over 6. Well, 2 pi is 12 pi over 6. So I want 1 pi over 6 less than that, so 11 pi over 6. Again, this is another thing that's just going to take some practice. All right, what about, let's do cosine of theta equals, let's stick with a half, but let's do positive a half. Well, cosine is positive in quadrant 1, but it's also positive in quadrant 4. And what is the reference angle when I take the cosine that I get a half? So if looking at my little triangles here, adjacent over hypotenuse that gives me a half is 60. So the reference angle, in other words, is pi over 3 in radians. So, well, the reference angle is a quadrant 1 angle, so that one's easy. Quadrant 4, so I want my reference angle to be pi over 3. So 6 pi over 3 would be 2 pi. So I want 1 pi over 3 less than that, so 5 pi over 3. And finally, just be aware of sometimes the ratio isn't corresponding to one of our special triangles. It could be a ratio of a quadrantal angle. So if I said, for example, tangent of theta equaling 0, well, then I want to think about, okay, tangent is y over x. So when is y equal to 0? And y is equal to 0 on the x-axis, so my answer would be 0 and pi. I'm not saying 2 pi because notice I have a parenthesis there, which means non-inclusive. So 0 to pi would be my answer. Okay, that was a lot. The more you practice, the better you'll get at this, like with most things. But this really requires some practice. 2, to just get familiar with the trig functions, but 1, to get familiar with the trig functions, but also 2, to get familiar with radians.